All right, good afternoon. So this is a rare time I'm going to be making a video for my pre-calc with Trig class. So my apologies if you're in the class because this is the same lecture I'm going to give you guys when we meet again on Monday, or Tuesday rather, whenever we're going to meet. But just to give you a preview as to what's going on here, we're going to be talking about inverse functions. So let me start off by drawing a little picture for us, and this is what we'll have. So if we talk about the sine function, okay, oops, I want there, okay. So we have the sine function, right? Here's 2 pi, pi, pi over 2, 3 pi over 2, okay. It's 1, negative 1, so going ahead and drawing our sine value here. And notice that this goes on and on and on forever and ever and ever. So the first thing I'm going to ask you is, like, does the sine function have an inverse function? Well, it fails the horizontal line test, doesn't it? So no, it does not have an inverse function. But what if, we restricted the domain here between here's pi over 2 and here's negative pi over 2? So if I just take this little snippet right here and this little snippet right here, and we just look at this domain, okay? This is negative 1. This is positive 1 up here. So if I just take a snapshot of like this tiny little, part of the sine, I've taken my calculus scissors and snipped it with just this little spot here. Now is it an inverse function? Like, well, sure, it passes the horizontal line test, so why not? So inverse sine does have, or inverse function, the sine does have an inverse function, which is called inverse sine. And we write the inverse sine as sine, I usually write capital negative 1 of a value, okay, of a ratio. And it also give us the angle that led us to that ratio. Okay, so one of the ways I remember this is, well, the sine of an angle, okay, is some kind of a ratio. The inverse sine of a ratio is some sort of an angle. Okay, so I must always go back to this when I'm trying to do a problem and I maybe haven't defined things well. It's like, what am I doing? Just to remind myself, like, what answer am I trying to expect? How do I interpret that answer, etc. Okay, there's an older notation which we use arc sine. This is also inverse sine. So arc sine of a ratio gives us some kind of an angle. Okay, so in your calculator, it looks like it's the second function sine button. See how it's yellow? It's like the sign with a negative 1 there, but it does not mean 1 over. That means the inverse of the sine. Okay, that's what that means. So we're not doing the reciprocal. That's called cosecant. You don't have a button for that. This is arc sine. This is a little bit different. So arc sine takes a ratio and gives you the angle. So a lot of times the way we solve these, and I'll start with the first one. I'll say, okay, what's the arc sine of inverse or of root 2 over 2? So we want inverse sine, okay, of negative root 2 over 2. Okay, and this equals something, equals an angle, equals a theta. So if I take the sine of both sides, okay, technically sine will undo arc sine, just like square roots are going to undo squares. And when I say that, I mean like mostly, but you have to be careful about domain issues. Okay, so if I go ahead and take the sine of both sides, it's not exactly right, and you'll see why in a minute, but it's important to see it's not an absolute value, is equal to the sine of theta. So the sine of what angle? I'm sorry, square root of 2 over 2. So the sine of what angle is equal to root 2 over 2? And you'll go back to your knowledge of trig and you'll say, oh, wait, that's pi over 4. But wait, which quadrant is it in? It's in quadrant 1. It could be in quadrant 2. No, it couldn't. It's negative. So This is pi over 4, 2 pi over 3 pi over 4. 5, it could be 5 pi over 4, but it could also be 7 pi over 4. Or what's a coterminal angle for this that's negative? So 7 pi over 4 minus 2 pi, that's going to be negative pi over 4. Okay, so either 7 pi over 4, which goes around this way, or negative pi over 4, which goes around the other way. Okay, just the negative angle. Right? So when we're doing this problem, okay, we're going to expect to be getting 45 degrees or negative pi over 4. Okay, so if I go here and do this, because again, one of the things you have to remember, sorry, we'll get to the calculator in just a second. What's the domain that we're restricting this to? Okay, we're taking this sign, so we're saying, okay, well, f of x has a domain, right, has the domain of root pi over 2, or pi over negative pi over 2 to positive pi over 2. And then the range is -1 to 1. We talk about the inverse function. Remember, the domain and the range flip. So in my, go ahead and do it this way. So in my, this is the sine function. In my inverse sine, okay, the domain is now, okay, or 1, -2, positive 1 here. Okay, but the range is negative pi over 2. It's positive pi over 2. So when I go down to look at this problem, okay, we get negative pi over 4 because that's the expected output of this function. Okay, so you have to be really careful, because if I just put a negative ratio in here, I could have meant something that was in quadrant 3 or quadrant 4, but I don't really know which is the proper one. So you have to be really careful about picking out which one you want. Okay, that's the tricky part. That's also why sine doesn't automatically undo inverse sine, or inverse sine doesn't automatically undo sine. You have to be a little bit careful, because there are domain issues that you're doing this. If you don't look too closely at it, then yeah, it works. But if you're going to look closely at it, and I guarantee you we will, you want to make sure that you've got your domains and your ranges lined up. Okay, so in this case, we get negative 45 degrees or negative pi over 4. So if we go ahead and do that, just guarantee you that it works. So if I say inverse sine, right, and we type in negative, we need this negative, and I want root 2 over 2. Where's my square root? There it is, square root 2, parentheses over 2. Okay, we are going to get, that's not right, that's negative pi over 2. I don't like that. Let's try it in degree mode, just to double check us. Say change it, and I want root first sine, and I want negative root 2. There we go, root 2 over 2, and hit enter, and then we'll call it a day. Negative 45 degrees. Why is that? I want to say that's pi over 2. That's not right. I may have messed up. Oh, I know what happened. Okay, I put the parentheses wrong. So the calculator thought I meant negative root 2 over 2. So it's the inverse sine of negative 1. That's going to tell me negative 90 degrees, or negative, or there's going to be 3 pi over 2, or negative pi over 2. Okay, so that's how that's working out. So I used the parentheses wrong for that one. Okay, so that's how we're going to be doing that one. So that's we ended up with negative 45. What did they want this in? Exact value. Okay, fine. They want negative pi over 4. Generally, they're going to want radians, but I'm tempted to check to see if negative 45 will work out. Let's try that. So let me go ahead and try as an experiment. We'll say -40. Oh, you know why? I can't put a degree in here. So I don't have a degree thing. That's why it's not going to let me do it. So that's why you have to type in negative pi/4. Okay, so that's what they're going to do for that. Okay, and then we get the little check mark and say, hooray, we can go on with our lives. Okay, so that's how we're going to deal with inverse sine. Okay, now inverse cosine is a little different. So cosine, same idea, right? We get the inverse cosine. We have cosine of an angle gives us a ratio. So the inverse cosine of a ratio returns for us an angle. Okay, but let's look at the graph of cosine. And does it pass the horizontal line test? You say, obviously not. It does not pass the horizontal line test. Look at that. There's no inverse. Okay. So what we're going to do is we're going to snip. We have to decide, like, where is it going to be one-to-one function? Like, well, any negative angle is not going to work out too well, right? Because it's symmetric around the y-axis here. So let's start with here and let's stop at pi. So we're going to go from 0 to pi. So inverse cosine is going to give us a ratio. It's going to give us the angle that's in the first or second quadrant. Okay, so we're going to get our answer is going to be somewhere between 0 and pi. Okay, so the input argument, right, is between -1 and +1, but the output value is going to be between 0 and pi. And we just have to remember, it's like, well, if it's negative, it's going to be in the second quadrant. Okay, so part of doing the problem is interpreting, like, which angle did you actually want? And that's where the tricky part is. Okay, so be careful with cosines, be careful with sines. Sines go from negative angles to positive angles. Cosines go from 0 to pi. So be careful when you've got negatives. Okay, what about tangent? Tangent is actually one of the coolest ones of all. It's tangent inverse of theta, or of a ratio rather, gives us back an angle. What's the graph of tangent look like? And the graph of tangent, right, looks like -pi/2 to pi/2. Kind of looks like that cubic. Here's our vertical asymptote. Okay, so the inverse tangent actually goes the other direction. Okay, so the input is any angle between, so the input for tangent, so for tangent, theta can be somewhere between -pi/2 and +pi/2. But what's the range? Range is -infinity to +infinity, right? It's all of them. It's all the numbers. So if we take a look at the inverses, okay, this is kind of cool. Tangent looks something like this. We've got an asymptote, we've got a horizontal asymptote, vertical asymptotes turn into horizontal asymptotes. Okay, so we have two horizontal asymptotes that are in different places. One of them is at pi/2, one of them is at -pi/2. So as the ratio goes off to infinity, it's going to approach pi/2. If it goes off to -infinity, then it's going to be -pi/2. So this is the one organic way of having two horizontal asymptotes. Okay, so aren't you glad we didn't have to deal with that with the rational functions? But that's pretty much what we're looking at for inverse tangent. So inverse tangent, we'll take a ratio, I want inverse, and will give us back an angle. That angle is going to be between -pi/2 and +pi/2. So first or second, or first or fourth quadrant. Okay, so we're dealing with angles here or here. Okay, this is where it could be. So if you get another negative angle, it could be, right, a negative ratio. It could be in quadrant 2 or quadrant 3. So you have to double check, like, well, where am I in the problem? What is this trying to explain to me? So you have to be really careful about how am I doing this. So again, tangent will undo or inverse tangent will undo tangent, inverse tangent will do tangent. But you have to be really careful about, like, well, sort of, as long as you don't look too close. Okay, so in general, yes, it does, but you want to be really, really careful about your domain, and that's where that's why this section tends to be kind of difficult. Okay, so let's go ahead and we'll continue. We'll do another one. Okay, I'll show you what I mean by that. Inverse cosine of 0. Okay, so cosine inverse of 0 equals what? Okay, equals some kind of a theta. So what I want to say is the cosine of what angle is equal to 0, pretty much taking the cosine of both sides. So cosine of what angle is going to equal 0? Oh, how about this one? How about pi over 2 or 3 pi over 2? Okay, and since I want to keep this to the first or second quadrant, right? This is the first quadrant. This is the second quadrant. I want to keep this up here. So we're going to end up with a pi over 2. So the angle of theta is going to equal 90 degrees or pi over 2. Okay, so we're going to be careful about that. Okay, so we're going to say this is equal to pi over 2. 2? 2. How about that 2? Okay, not F2. Okay, we'll go on with our lives. Okay, it also could have been something in the fourth quadrant, but generally you want the primary one. Okay, and then find the exact value of the inverse sine of negative a half. Okay, so this is why you guys had to memorize this, although again, I'm not quizzing you. It's like it's not like you don't have access to a calculator at all times because you have a phone in your pocket, but you should, there's certain ones you should kind of know. Okay, sine inverse of negative 1/2. And so this equals some kind of an angle. So the sine, effectively I'm taking the sine of both sides. Okay, the sine of what angle equals negative 1/2. Right, and remember we're talking about first or fourth quadrants. So we want angles here, we want angles here or here. So where's sine theta equals 1/2? We're going to get 30 degrees, right, or pi over 6. But we're also going to get negative 30 degrees or negative pi over 6. Okay, so we're going to write a negative pi over 6 because we don't have a degree to type in. So we're going to say this is equal to negative pi over 6. Check. And look at that. Okay, maybe one more. And I'll let you guys have a moment to think about this one. So again, it's the hardest part about this is just remembering, like, you have to check to see like which quadrants you're in. Other than that, these aren't too bad. These are a lot of calculator exercises, because if you don't have these special ratios that you happen to know the angles of, or you're at least expected to at some point in your lives know the angles to, then you have to pretty much use a calculator, and you have to interpret the calculator to actually get your answer. Okay, so that's what we're going to be doing here. And again, I would automatically recommend that, it's easier to put this in the mode of degrees, so you can kind of see where it is on the circle rather than looking at a huge decimal place. So if it's negative 45 degrees, like in your mind, instantly you know where that is, but you may not know where like negative 0.73 is. Okay, you just don't know that. That's okay. We're not expecting that. Okay, so this one, cosine inverse of negative 5 equals. Okay, so cosine inverse of negative 5 equals what? Equals some kind of an angle. So if I take cosine of both sides, right, we have negative 5 equals the cosine of what angle? Remember what the graph of cosine looks like. Right? Cosine starts up here at 1, starts down here at negative 1. So we end up with cosine looks something like this. Right? Here's negative 5. Where along this cosine did you ever get down here? It never happened. This graph never intersected this negative 5 line. Okay, so this is nonsense, because this is outside of the range, or it's outside of the domain. By typing in the calculator, you're going to get domain error. So this is an undefined problem. We're not going to get anywhere with it. Okay, we'll go ahead and check, because this is absolute nonsense. So check equals, and I'm going to say undefined. check, say hooray. Does double check it on the calculator, so just so you see what it looks like. So you're not going to look at this and say, hey, what does this mean? Inverse cosine of -5. Okay, you're going to get domain error. Okay, but that's why you're getting domain errors, because look at where the cosine is. I'm like, look at -5. They don't offer me. So inverse cosine ain't going to give you a -5 anywhere. Okay, there's no angle here that ended up going down all the way down to this. Okay, so that's pretty much the intro part of inverse functions, and we will do some more in the class. So thank you for tuning in, and I'll see you next video.